Today we have Bharath, who leads the SSP SDK team, while Sunil and Nayak have been part of the team for about 1 year and 6 months, respectively. So they focus on strengthening our SDK while introducing and adopting the latest practices that are there in the industry. They have also been working on the release process and migration of SDK to Kotlin, which aligns with the topic of today, which is Kotlin as a programming language for mobile applications slash SDK. So over to your team.
Yeah, thanks, Vaibhav. Thanks for the brief intro. Good morning, everyone. I am Bharat. I am working as an engineering manager for SSP SDK teams. So I am leading both Android and iOS development efforts. So today I have along with me Sunil and Nayak, who are representing our Android team. Today we'll be discussing on Kotlin as a programming language. So ever since we started our Kotlin migration couple of months back, so we have learned a lot and we got a chance to understand the language in deeper. So Kotlin is a language which was started in early 2011, but over the years it has evolved pretty well. The moment Google acquired Kotlin and it has uh, started announcing that Kotlin is going to be an official language for Android development in 2019. So the developer community has really adopted Kotlin pretty fast. Now we have a huge developer community for Kotlin. So most of the applications in the recent years has been started with Kotlin instead of Java. So, and not only that, during our migration, we even felt that it is as good as starting a new application in Kotlin. And the migration part is so smooth because Kotlin has the interoperability capability, which is we can work with both Java and Kotlin together. They both understand each other and all the DEX files and everything are pretty smoothly converted and the compiler can work with the two languages, which is a huge plus. And coming to the Kotlin, right, it's an open source backed by Google and we have huge developer community. Uh, so not just the mobile application development tool, it has evolved as a multi-platform tool, I would say. So in the coming years, we'll get a chance to see Kotlin as a development language for web applications, as well as backend applications, and even iOS applications as well. So the strong advantage that we have as a multi-platform dependencies, the modules can really reused across the platforms. So to give you more details about this tech talk, I would like to ask Sunil and Nayak to present the deep dive in the Kotlin and as well as show the demo applications, how it used to work in Java, how it is better in Kotlin. So over to you, Sunil.
Thanks, Bharat. Bharat, you stole away a lot of the information I was about to present. So, yes, Kotlin is open source and it's a growing community. It's having rapid growth post Google announced support for Kotlin and Android, and in 2019 it has announced as Kotlin first. Android as Kotlin first would be going Kotlin first. So it's originally developed by JetBrains, and you know that JetBrains have excellent IDEs. They are into compilers, and I think they have understood the problems of what generally all language, what problems we face in most of the languages. They have got the best and try to deliver them and address them in Kotlin. So I would like to um, build up that Kotlin is sometimes you can find a new feature in Kotlin, but overall you can see that Kotlin is doing a lot of the features that are existing in other languages in a better way, or giving them out of the box without external support from libraries, etc. So it's a statically typed programming language. And as Bharath has earlier mentioned, Kotlin is multi-platform. And right now, the Kotlin multi-platform as a whole is still in alpha stage. It should be going beta in spring 22. We expect more and more users. There are different parts to the Kotlin multi-platform. We have Kotlin JVM, Kotlin JS, and Kotlin native. Kotlin JVM is the most advanced, and I think it is in production state. Kotlin native is still in the alpha stage. So we have rapid development in all these sections, and within very sorry. I thought the slides are moving. Can anyone confirm that? Are they moving, or should I represent?
Yeah, Sunil.
Yeah, actually, you need to sync up with presenter. So when I did sync up with presenter, now it's moving.
Okay.
So there is one option bottom of this.
I'm actually changing them in the Teams app itself, and it is immediately showing up for me, and I'm not working on the presentation. Okay.
Yeah.
Since it works.
Yep.
So yes, not all platforms are production ready yet, which means that we can be part of the growing. We are early on onto this growth of Kotlin, and we can take advantage of it, and of course give it shape and contribute in whatever ways we can. How does how is Kotlin able to address all the platforms? So with respect to JVM, Kotlin made sure that from the start, they actually came up with Kotlin JVM first. They converted, got the language into Byte Code, Java Byte Code, which is like the most used on majority of the machines today. Okay, so they made sure that they are compatible with the existing machines. So that gives a huge plus point to Kotlin. For Android, of course, the Java bytecode gets converted to Xcode and run by ART. So it's pretty much straightforward there. With native, I'm not sure how many of you are aware of this. So just giving a more deeper understanding of it. So if you're aware of the LLVM standards, so we have a LLVM compiler for native. So all the code that's generated would be standard across all platforms with respect to the LLVM bytecode. Later, this bytecode is converted into machine code based on the machines that you require. Like say if you're building for Linux or Windows accordingly based on the architecture that you're trying to build it for again. Same applies for iOS, macOS. With respect to JavaScript, the Node for Node and general browser JavaScript, we have a Kotlin compiler which directly converts the Kotlin code into JS files. So again, JS files are like fed into the JS interpreter, JS compiler. So and I'd like to say that Kotlin is multi-paradigm. It doesn't enforce any programming form onto you. In fact, it helps you. It encourages you to use whichever paradigm is comfortable for you. Going forward, we'll show you examples on how we can do this. and it makes would say a lot of the say functional programming. It does aggressive type understanding of return types or functions in general, which helps to make the developer life much easier. We don't need to go change the definitions of functions that we have mentioned around because of this, especially in lambdas. Yes, it also has reactive support and object oriented. The biggest plus point, Kotlin is interoperable. It is not actually competing with any other language. In fact, it is trying to give the best that it can give. So you don't have the overhead of converting your project entirely. You can go piece by piece. And once you are more comfortable, you can take it as you want. If you feel you want to stick back to your original methods, it still gives you it still keeps the door open for you. So there's no headway that companies actually need to go through. Best part with Java, at least, you have Kotlin files sitting right next to it. Though for the native platforms, you would have to have them you would have to get them converted into a library files before you actually use them in your native code. Features of Kotlin programming language. This is a small set. I would like to hand over to Nayak to explain each of them in detail. We'll be showing you code snippets and show you how beautiful Kotlin is. Thank you.
Yeah, thank you so much, Bharath and Sunil. I'll just share my screen. It's visible?
Yes.
Yes, sir.
Yeah, so yeah, let's do Kotlin and basics in 20 minutes. Yeah, so basically we have, let's start with variables, right? So defining variables, we need not mention the data type as such, like for example, integer or string type. So the compiler knows by itself, like for example, we are assigning 0 here. So we check it and it's an integer, and here this is a string. So prior to that, we have a couple of things: variable and value. So variable, we can sort of change its value, and val is basically it's final, right? So you cannot change it at any point in time. And like these are classes, but you cannot sort of assign null values to it. So how do you assign null values to an integer or a string or any other class data type variable? So there is something called as a nullability. You just put a question here, and it actually becomes a nullable object. So let's try to let's look more detail. So here we have a optional string which is nullable, and we can assign a non-null object to it, variable value to it. So while on the other way around, like we have a non-null variable and we try to assign a nullable value to it. At compile time itself, we sort of get an error that we cannot assign values to a non-nullable object. In Java or any other language, we write setters and getter methods to any variables, right? So here in Kotlin, we can just write set. We can whenever we sort of receive a value to it, a value, and we can modify as per our requirement, and just assign it back to the field, and this is basically the reference to this particular variable. And likewise, we also have get and return some value here as well. For example, if I field dot a to string or something like that, you can basically modify here as well, right? So yeah, this is accessing and assigning values to a variable has been made easier here. So going next, we have this boolean string, any of the classes we write, class objects, integer, long. Basically integer and long will be extending the number class, and all these the parent, just like in Java we have object class, in Kotlin it's any, right? So everything will be extending any um, class, right? So, and it's in nullable objects, it's any nullable any object, right? So yeah, that's how the hierarchy looks like in Kotlin classes. So coming to data class, right? So here let's look into Java ones. So here in Java we have any data class we write, which constitutes of variables, and here we sort of declare variables, for example first name, last name, string, which is of type string. We have a constructor, we have getters and setters. If we want to compare, for example, two objects, we should be overriding equals, and also include hash code, also override hash code along with it, right? And clone to string, and all these, this is sort of an overhead, right? But Kotlin actually has come up with just one line of code. You just declare whatever variables you wanna mention, you wanna have that in that particular class, and the compiler generates it for you. So let me show you the byte code ones. Uh, um, Byte code, yeah. So this is pretty much hard to read. So let's decompile it back into Java. Uh, Here you can see this Kotlin full name class, which is assigned final. We have these two variables here. We have getters, setters, and yeah, getter setters for last name, first name. We have the constructor here as well. These are two additional methods being added, like component for every variable. There will be component one, component two, and component en up to n. So we have a copy function being overridden, and to string. It basically makes you gets you all the variables, and uh, tries to generate a string out of it. Hash code equals, and like basically what all functionalities you need, just generates it for you. Right. So basically the type of the class is data class. Yeah. So whenever you like mention data class, so all this code will be generated for you by the compiler. And coming in, let's run this. So basically what we are trying to do here is we are trying to generate an object, Java object, and with these variables, and yeah, like the same, we are trying to clone it, we are trying to print that particular object one, trying to compare these objects, and also trying to print the hash code of it, and trying to print the third of the clone of the object that has been generated, and likewise in Kotlin as well. So let's try to run just. Yeah, as you can see, this is what is generated from Java object class. Like there was so much code, around 90 to 90 lines of code there. But here we have Java full name. All we only had to handle it to get this string and stuff like that. So, and we sort of get the same output using Kotlin data class. And yeah, it's just one liner there. Um, Yeah, that's about data classes. Let's get into objects. So what are objects? Basically, objects are singleton classes, right? So you need not handle creation of classes with, thread safe and all that stuff. This object class does it for you. It's a singleton and you can directly access methods, a preference, the dot get string and get settings one. So it will just print this in a sequence. Um, yeah. So every function will return type is of unit, right? So if you don't mention what is the return type of any function, it's of type unit by default. So yeah, that's from the object classes. So talking about extensions, why extensions are needed. So for example, you want to add additional functionality to a string object, for example, but doing that in Java, you will have to extend, you'll have to create a class, you'll have to extend it with string class, write methods to it. But in Kotlin, you just mention what object type it is, and you just write what the function name is and what the return type is, in case there is any. So, uh, and you'll be able to get the reference of that particular object, perform operations on it. And yeah, that's how you can add additional functionalities to a particular with existing object class. Yeah, here I'll run it. Yeah, this is how basically this Malayalam variable is actually, of type string, because we are assigning it with string value. And yeah, we can basically call this is palindrome method. Basically this that was a method, and here we have extension type property as well. So here basically we are trying to add additional functionality to integer class, and here we are trying to convert it into a binary. 10 is getting converted to binary, so we just have to do this, and you'll write a getter for it, and you'll be able to this particular function will generate a particular binary with a radix 2, right? If we try to convert a 10, then we have the output 1010. Yeah. Yes. So we have filter classes, filters as well. So what does for example, you have a list of integers, and you want to actually sum even numbers of it out of it. So you just have you can attach a filter. Basically, this will, whenever we sort of receive a true for this expression, then those numbers will be filtered out, and you can and there are multiple functions in in filters, and you can actually make use of it. And here what will happen is you are summing either even numbers, and finally we are just sort of printing it out. So likewise, actually we have multiple ways of and uh, iterating through sort of numbers and stuff. Here there is one more through the list. So here we have one more way of doing it, right? So for and for each and every integer in a particular list, for example, it can be any object. For example, if I change it to long or any other object class, so you can basically try get each and every object of it, and perform operations inside that particular for loop. So here we are checking for the condition, and we are just summing it up. So what is this function? Basically, this is a block which actually measures how much time did this particular block of code take to run. So I'll be later point in time, I'll be printing it out, like how much did each and every function took to execute it. So next is we can also make use of indices and get objects from the list, right? So here we have size and assigned with the size of the list, and we have indexing from 0 until the size, basically until is size minus 1. And one more way of doing it is we have uh, this is basically iterates from 0 to size, but we want till until only size minus 1. So here this is one way of doing it. So yeah, basically doing so you'll be able to iterate through the lists and that's and make use of for statements. So here I was basically generating a random set of numbers uh, of up to 1 million, right? So shuffled, and let's try to run this. Yeah. So as you can see, I mean, this filters, total sum, everything is same across, and like we have, this is taking pretty much amount of time, and we have 16 with it. This iterator make basically what happens is while we sort of make use of this, it creates an iterator and tries to run this, but this is an indexing mechanism, so it wouldn't create any iterator. It's just accessing from that index. um, so yeah, so let's go into scope functions. So here we have defined a view details data class. Basically, it contains a length object, length variable, breadth, and for example, we want to write a function to fill these details of area, perimeter, and e-square. So consider we have written a function which takes in that view as view details as an parameter to it, and we want to fill all these variables inside it, right? So we can basically I mean what we have will be doing was is view dot area. Everywhere we can see view, right? So we can sort of simplify it just like this. uh, Apply. So basically what happens here is whenever you sort of apply on any object, you can directly access the variables inside that particular object class using apply. And here also you can yeah, yeah, that's it. Like you can just you'll for every variable you can assign new value to it, and that actually updates the object values. And yeah, so here you can make use of apply here. So we have one function. Basically what this function is trying to do is create we have a mutable map with string as the key and view details as value. So we want it to be thread safe. So this, I mean, it's a lot of code, right? Here we have some 15 16 lines. So we can sort of simplify this a little bit more. So how do we do that? So consider we have view cache, and we are trying to get shape id. So I mean there is a possibility that this can be null. So how do we handle it? So we have something called as Elvis operator. Basically what happens using Elvis operator is that if the if this particular value is null, so we want something else to run and return. So we write it here view lock, and inside this synchronized block we want to return a new we want to return the value which is expected, that is view details with this particular key. So how again in the synchronized block view cache shape ID, and again if this is null, so we return, we have sent a default value, so we return that, right? So it's just this much. So one more thing that's missing is like along while we are sort of while the value is null, and we want to sort of do additional operations along with it. For example, we want to print or do certain update certain details of that new object. For example, apply something like this, or just while returning, you can do also. So just before returning, what it will do is it will execute this block, and you just can print it here. Yeah, it's just 4 lines, and you sort of receive the same result of it. So in Kotlin, how does this block inside a block work? So inside synchronized, we are actually not putting any return, right? So the compiler knows that whatever has been written inside it has to be returned, and you can just mention one return at the very top level, and things will be returned there, any value from this block, right? So with scope, actually you mentioned, you put view as a parameter to it, and likewise you get the reference, and you will be able to access the objects of it, right? So so let's look into more detail, like how are these two different. So in with, actually we have a return type, returning whatever we are sort of returning inside the block, actually that gets returned as returned with the with block, right? But in case of apply, you are trying to apply on a certain object, and the same object will get returned ultimately. Yeah, I mean there are many of like there are 6 to 7 scope function, and yeah, these are the 3 ones here right now.
Would like to add here that the Elvis operator or the null safety provided from Kotlin solves the like $1 billion mistake of null pointer exception that we go through on a day-to-day basis. So makes our life much more easier and safer.
Yeah, so yeah, yeah, expression classes. So for example, we want to create a list, or hash map, or yeah, map of objects and stuff. So we have certain already functions for it, and you can just write it something like it contains a pair of objects, right? So this is actually looks more verbose, right? So uh, there is a better way to do this as well. So just write to, and yeah, here you have it. So it's just this, you are trying to assign key to a particular value, and so this basically creates a pair, and it sort of inserts it inside the map whatever we are trying to create. And this is an unmutable map. If you want a mutable, we have mutable map of and stuff like that. So for printing a particular map, what we are trying to do is like we are trying to unwrap each and every object inside this map. And while unwrapping, we sort of get, while whatever variables we mention inside curly, these braces, that value will be assigned to those variables, and you are since you are putting it inside a for loop, you'll be able to run it across all the objects inside a particular map, and here we are trying to print it. Yeah. So what coming to when, it's pretty much similar to switch case. It's used in place of switch case. So here we have what's A, B, C, D, E, G, H, and else cases here. So everywhere we want to, for example, we want to return some result. So I mean, for example, is of type first category and stuff like that. So, I mean, you can instead lift return statement out, just like, I mean, the compiler knows that for this case, this is the value that is supposed to be returned, and yeah, that's how it is. Like here we see common stuff, just like I mean, we can just put it here itself, and yeah. So yeah, this is how you can, make use of when statement. Uh, yeah, coming to nullability. Yeah, as I mean, there are a couple of ways of handling nullability. So this is one way of doing it, forcing that actually the string. For example, we have a string that is coming into this function, which is of type nullable string, and here you are sort of forcing that the string wouldn't be null, right? So and you're trying to print it out. So for example, you force it and you're trying to access certain parameter like length or do certain operations on it, then if it in case it turns out to be null, then it would actually cause a null pointer exception itself. And yeah, so um,
Do mention how we avoid that also, so that
yeah, and the next. So like for example, we have a string. I mean, here we are checking for a null of string, right? So here we are trying to iterate through each and every character of this string. So we can sort of handle this. I mean, consider uh, we try to bring it outside, and we remove this, and we get sort of get an error right now, saying that this is of type nullable and you are trying to perform operations on it. So either you have to do something like this, or there is one more way of doing it. You are being safe here. So you are doing performing operation safely on a particular object. So what happens in this case? So in case the string object is of type null, then this wouldn't get executed at all. Yeah, that's how it is. And for example, string here we are writing if condition. Again, we can reduce the code str, put else operator, return null, and yeah, this I mean this actually makes the code more concise and make use of different operators out there available in Kotlin, and you can simplify stuff. Yeah, that's about functions, expressions, and so yeah, here we have I mean, consider directory structure. We have direct I mean, which contains folders, and each and every folder might contain additional folders, and we have it might even contain files and stuff. So here we are I mean, here we are trying to construct the same. We have a directory which is I mean, named main directory. Inside that we have a profile directory, we have files here, documents and documents directory, and we have files inside it. So consider a case where we want to extract all the file details objects from this, right? So here we have this function which is an extension function on component which is an abstract class for now, which where directory and file details are extending it. So we have created a mutable list, and so this is one of the advantages. For example, if you know that a particular function is only used by a certain function, and so you need not put it outside inside a particular class, and make it private and all that stuff. You can put the same function inside that particular function, and it becomes local to this extract all file details, right? So here what this function basically is doing is it's a recursive function which checks if a particular component is file details. If it is file details, then it adds to into this, and if it's directory, then it again calls the same function. So yeah, let's see it in more detail. So we have this component c coming in as a parameter. We are checking if it's of type file details. So I mean, here, as you can see, it only takes in this list only takes in file details, right? So we are not typecasting C actually. So we are directly adding it. So the compiler knows that this is of type file details, so it wouldn't need a typecasting while you sort of code it out. Uh, and likewise, if C is of type directory, then we can access a variable of it inside that particular object component, and you can iterate through it and call the same function again. Yeah, this is the error handling. So let's try to, I mean, we can even replace it with when here. We are trying to pass it the object here, and is of type file details, then execute this block, is of type directory, then execute this block. So if you want to, avoid error, I mean, case handling and stuff like that, so we have something called as sealed classes. Sealed classes. So as you can I mean, since component is only extended by directory and file details, so this when function, compiler knows that these are the only two possibilities and it's already handled. So that's the reason else is actually being, I mean, it wouldn't get executed at all, right? So you can sort of remove this, and yeah, this becomes more easier uh, with handling certain, I mean, switch cases and stuff. So let's, I mean, here we have a function which tries to construct the folders, and we have a component returned from it, and you are trying to call an extension functions on it, or even write it as a value. Yeah, these are the two ways of doing it. And let's try to print it out, right? So as you can see, like this, we are getting some details here, like I mean, object. That's because I mean, this is of type class. So let's make it data class. I mean, you can data class, and you will be able to see it much more clearly, right? Yeah, here we have file details, file name, and all the variables constructed in a string format. Going next. So here we can also sort of return a function from a variable or any other functions. So here we have an inner function, and we have defined it as value, and yeah, you're trying to return that. So this is the return type, like this function, and which is of type unit, right? It wouldn't return anything, this inner, so it is of type unit. And yeah, this returns it, and you can try to invoke it, I mean, get the outer, invoke it, and you will get, using this you will get the inner function, and you try to invoke that as well. So it will basically print whatever data that has been, I mean, variable that has been assigned with. And here we have written one more function which tries to again return a function. I mean, what happens is this basically I mean, whatever you sort of write inside these braces actually talks about what parameters it takes in. Since there are no parameters, then here we just have open close braces, which is of type return unit, return type unit. So yeah, you can return inner function, and you can just invoke it here.
Would like to add here that I'm not really sure how much advanced the Java recent versions are, but with respect to lambdas, you can see that you can return a function itself, and that makes Kotlin work as a pure functional language as well.
Yeah. Yeah, right. So let's go into inline functions. Here we have we have a function inline, marked with inline. Why is it needed? So let's consider we remove this, and Kotlin Byte Code. And we try to look into, let's look into, try to look into the bytecode of it, right? So here we have, yeah. Yeah. So what's happening is we have a string that is getting assigned with this string, and we are calling the response validation. So here we see that a new instance is actually getting created, right, every time if we try to access a static function. But inlining it, that's where inline comes handy. So marking a function as inline actually a new instance wouldn't get created. Instead, the whole code snippet would get actually replaced there. And yeah, you'll be, as you can see here, actually the handling of success and failure will be in the main function itself. Yeah.
With respect to inline, I think Java does it at a JVM level, where you kind of keep a buffer of how many times a function gets hit, then it is turned into an inline function automatically. But over here, we can take advantage of inline functions. Especially, it gives a lot of help because our readability increases. At the same time, performance doesn't decrease. So especially when you have lambdas passing over, you don't want to build up a function stack unnecessarily, and mentioning inline actually saves a lot of performance.
Yeah, that's right. Actually, it's I mean, this becomes more efficient only when we have a particular lambda function being passed as a parameter to any function. But I mean, for example, we write one more function. And this is a very simple function, so which is not taking in lambda, right? So if we try to mark it as inline, I mean, we sort of get a warning that, I mean, it wouldn't impact very much by inlining this. So yeah, that's how it is. Yeah, so you can remove inline here. And coming to lambda functions. Here actually we can, I mean, one of the things that we can do in Kotlin is we can pass functions as a parameter to another function here, for example, we want to check if the particular response is valid or not, right? So here we have certain condition, like if it's blank, then if it's not blank, then provide it with success, and otherwise failure callback. So what this callback is, it's a basically function which takes in response enum as parameter, and its return type is of unit. So response enum basically contains success and a failure. So here we are sending some empty string as part of the parameter, and here we are actually implementing that lambda function. And yeah, here you just start trying to print whatever we sort of get as a callback, either success or failure. If you want to pass additional parameters along with the callback, for example, some integer, it's actually pretty much easy here. Like just put and here as well. So consider here. It's just this response code. I mean, you basically need to mention what all variables are you consuming as part of the callback, and yeah, you just can perform operations on it. Yeah, that's about lambda. So here actually, if you see here, we have a particular variable actually, which takes view as a parameter, and returns boolean. So we are trying to, for example, we have button and spinner here, which are basically view classes of Android, and we are trying to set listeners to it, right? So for example, long click listener or context change listener. So we are trying to pass the same variable, and here as you can see it actually takes in, since the thing is that set on click listener takes in on click listener, which has a function which takes in view and returns a boolean on long click, but while the other one, the context change listener, takes on context click listener. But, the idea here is both takes in view as parameter and returns a boolean. So yeah, here you can make use of the same variable and for both the cases, right? Yeah. Uh, yeah, that's about functions, and yeah, delegate class. So here we are trying to for example, if you want a particular variable to be initialized, not while during creation of certain object class, I mean class object, yeah, then because it probably takes so much time or some things like that to be initialized, so you do not want memory allocated to it at the very in first instance. So we have something called as lazy. It's basically thread safe, and I mean basically it tries to when multiple threads are trying to access it, it just creates one instance and returns the very first value that has been assigned with it. uh, so yeah, so let's see. Let's run this. What we are trying to do here is we are trying to create a delegate class, sleeping for couple of seconds, and once the couple of seconds is finished, we are trying to access it, right? So, and while we are trying to access it, then it will get initialized. So let's run this again. Here we are sleeping for 2 seconds, the variable did not get initialized, and after the sleep has finished, we are trying to while we are trying to access it, so the it gets initialized and then the value gets returned as, yeah. Let's get into observables. If we want to listen to a particular variable getting updated every time, so here we have a delegate property which wherein you can assign with a default value, and every time it sort of updates, you can do operations inside this function, lambda function, and yeah. For example, here we are assigning initially assigning it with Bangalore and to sleep for a couple of seconds, and we are trying to assign it with a different value. So every time you assign a value to it, it actually prints the old value and a new value as part of it. Okay. So yeah, here we have the initial value was empty and it gets updated to Bangalore to Mysore. Um, Coming to coroutines, right? Spawning threads it's pretty much a costly thing, right? So here we have a first function which actually creates a number of threads. Like we have 10,000 threads here, and actually we are sleeping for 5 seconds, and we are actually printing that whatever variable number is, I mean integer number is, and actually we are actually doing this particular operation inside the thread, and we are starting all these threads, right? So I mean it actually is a very costly thing. So let's try to run it. uh, Unable to create out of memory. Yeah, it basically gives you out of memory exception, because I mean there are so many threads which we are trying to run. But in Kotlin we have something much more I'm like easy to do, and less costly of a thing, and it's lightweight as well. So we have something called as coroutines. Here what we are trying to do is we are trying to create a coroutine scope, and we are trying to launch multiple coroutines inside it, coroutines inside it. So it's I mean we have put the same block of code inside this, and we are trying to create of 10,000 coroutines inside this particular scope, right? So let's run this coroutines. Yeah, we see that, I mean, it pretty much runs the whole 10,000 without any hassle, right? So yeah, I mean, the threading actually pretty much is more simple here and less costly. So yeah, so let's come into flows a little bit. For example, you have a certain values being continuously sort of received over time, and you want to capture it, be alive, and you want to capture it here. So we have something called as flowables for it. So consider we are generating a series of Fibonacci numbers, and we are trying we have mentioned it with type flowable, and we are emitting the initial value 1, and every time we perform operation like add these two numbers and go, I mean, it's a Fibonacci sequence, right? So before emitting the very next number, we are keeping a 500 millisecond delay, and after that we are sort of emitting the next value, and that's we are trying to, I mean, we have to put it inside a flow block. So we sort of attach a collect to that particular function, and we are trying to print it out here, and those functions should actually be called inside a suspending function. What is a suspending function? So suspending functions basically tells the compiler that I mean, it does not get directly completed. The system should actually wait for a certain period to get for this to be completed, right? It gets actually suspended, waits until this particular block of code gets completed. uh, so let's I mean, what this main block is currently doing is it's trying to print out the current thread, and we are trying to create a scope, and we are trying to print the what is the thread here inside this block, and collect Fibonacci numbers, calling Fibonacci numbers. And here what we are trying to do is we are again creating a coroutine, and after 10 seconds we are trying to cancel this particular job, right? We are getting a job here. Every time we try to create this coroutine, we sort of receive a job, and we can cancel it at any point of time. So we are trying to cancel it here. To keep the main thread alive, we have put a job.isActive while loop. Yeah. So let's try to run it for 10 seconds, and yeah, let's see what happens. Uh, Here, as you can see, initially it was on the main thread, and after that, while we sort of create a new coroutine, and it gets moved into a, a worker thread, and after 10 seconds, actually you see that we are canceling the particular job, and actually that job gets cancelled, and it's active, and is active becomes false, and as a result of it, the function, I mean, this thread will get this while loop will be exited. So one more similar example here is, I mean, we have this similar code here. I mean, here print current thread. We have a job, and which is trying to make pizzas, right? So basically, we initially what the process is doing is it's creating a DAO object, and next we have pizza bread. Basically, pizza bread actually makes use of dough, and we have cheese. Once these requirements are satisfied, then only we can actually make use generate pizzas out of it. So we have one flowable which a flow function which actually generates dough. This is dough producer which generates a list of dough objects. So for every 1 second, it actually generates a DAO with random frequency, right? And it actually adds it into the list, and we sort of emit that list, right? So this particular thing is actually consumed by the where is this? Choose producer. Yeah, pizza bread. Sorry. pizza bread, and it's actually consumed by pizza bread. So what this pizza bread is doing is it actually takes in each and every dough object, and it actually emits a new pizza bread with same index, right? So well, basically what we are trying to do is transforming that object into a new pizza bread object. And that is in turn, I mean, we have one more producer, that is cheese, which pretty much does the same, like emit a cheese object every 600 seconds. And yeah, so these two are consumed for generating pizzas. And this is again a flowable of type pizza, return type pizza, and pizza bread is zipped along with cheese producer. And yeah, so here we are sort of emitting pizza, right? um and yeah, the same has been is being getting collected inside make pieces object, and this is again a suspend function which is called in the main function in the coroutine scope, right? So every suspend function is supposed to be called inside a coroutine scope, I mean inside a coroutine or its scope, yeah. And yeah, let's try to run this as well.
So the idea we are trying to convey here is that it supports reactive paradigm out of the box, and you can use it smoothly for reactive programming as well. It's basically a pizza chain where pizzas are created based on the pizza breads and cheese, and pizza bread is created from dough balls.
Yeah, we can see that cheese object, I mean cheese is emitted initially, and a dough is emitted. I mean there are 6 dough objects emitted initially, and from each object, the respective piece of bread is being created for every probably 600 milliseconds or such. Yeah, 100, right? So every 100 millisecond that it is being emitted, and likewise the cheese is emitting for every 600 milliseconds, and once we sort of once these requirements are met, the pizza is getting emitted, right? So yeah, and we after 10 seconds we are canceling that particular job. Yeah, yeah, that's probably about it from I mean the presentation point. Yeah, Sunil.
Okay. If you all have any questions, you can definitely unmute and ask them, or you can also put it in the chat box and they'll definitely get back to you with it. Uh, Thank you so much, Bharat, Nayak, and Sunil for taking us through Kotlin as a programming language overall. And yeah, if we'll be sending a feedback form, and we will also, if you have any topics in mind, please feel free to share it with us. And we will be sharing this recording as well with you over mail. Thank you so much, and have a great Friday.